Okay, so a few of you emailed me and had asked for more videos going through graphing to help you prepare for the exam. So I'm just gonna make up a few problems here and graph them. So suppose we have f of x equals 4 sine 2x plus 2x minus pi plus 3. And we understand first I have to figure out what all the transformations are. I don't want to just pick a bunch of x values and plug them in and try to use that to sketch the graph. We want to be able to understand it. So first we have to figure out what all the transformations are and then kind of go from there and build it. And if we look at this, we know right here the constant out in front gives me my amplitude. So my amplitude here will be 4 right there. I know whatever I add or subtract on the end will shift my graph vertically, so a plus 3 will make me go up 3. Then we remember on the inside here, I have to manipulate this and factor first before I can figure out the transformations. So first, factor out the 2, and I'll just write it over here. I have 2x minus pi, so I factor out the 2, which leaves me with x minus pi over 2. And again, we mentioned this before. Understand that even though there's no 2 in here, I can still factor out a 2. Whatever I factor out, the coefficient of x, I just divide by it over here. So now I have this, and then whatever I add or subtract on the inside shifts me horizontally. And let's see, subtraction usually goes left, which means now, since it's inside the parentheses, remember from 171, I go right. So this will go right pi over 2. And then the 2 out here will affect my period. And we said the trick was, my original period was 2 pi, since this is the sine wave. I do 2 pi over that coefficient 2, which gives me pi. And if you think about it, multiplying by 2 should speed up your wave. You're multiplying it by a factor of 2. My original period was 2 pi, now my period is pi. It's half as big because the wave is going twice as fast. So the logic of it actually makes sense here. Now, I should be able to sketch my graph. And there are different ways to go here. For the purposes of this, we're just going to sketch one period of it. There are different ways to go. Personally, I find the x's, I find the y's, then I just create dots and connect them. In this case, a sine wave normally starts at x equal to 0, right at the origin, but I shifted left pi over 2, which means now I'm going to start, that's right, pi over 2. That's my starting point. Now I find my ending point. And the easiest thing to do is to take my starting point, pi over 2, and then add my period, which is pi. Let's see, common denominator is 2, so multiply that by 2 on top and bottom, 2 pi plus pi. That's 3 pi over 2. So that's my ending point, and we've established on the graph, just because this graph is going faster, don't feel the need to draw incredibly small graphs. Several of you did that on your homework. I'll still space it out so we can see it. So we'll say my ending point is 3 pi over 2. Now I have the starting point and the ending point. Find the midpoint. And the easiest way to say this, as I've said before, you can just drop the pi if it helps. So I start at 1/2, I end at 3/2. What's halfway between 1/2 and 3/2? 2/2, which is 1. Then I put the pi back, so it's just 1 pi. Now I need to find the 2 midpoints of each of these intervals. And again, if that's 1/2, and that's 1, and that's 1.5, halfway between 1/2 and 1 is 3/4, so 3 pi over 4. And then halfway between 1 and 1.5 is 1.25, which is 5 pi over 4. And while this one is pretty clear, the trick that I had mentioned before, if this is confusing, I have 1/2, I have 2/2, and I have 3/2. If you're having trouble finding these 2 midpoints here, which are usually the harder ones to find, multiply everything by 2. Double the denominators, which means double the numerators. then I would get 2 over 4, 4 over 4, and 6 over 4. And then once you do that, now the midpoints are easy. Halfway between 2/4 and 4/4 is clearly 3/4. Halfway between 4/4 and 6/4 is 5/4, which is exactly what we got. So there are different tricks, like I said, to kind of figuring out all these values. But those are all my x's. Now I find my y's. Normally, sine wave starts at 0, goes up 1 and down 1. But I shifted my graph up 3, so instead of starting at 0, we'll go up 3, we'll start at 3. And then my amplitude is 4, which means from equilibrium, I go up 4 and down 4. 3 plus 4 is 7, 3 minus 4 is -1. Now I have my x's and I have my y's, sketch my graph. The sine wave starts at equilibrium, which for me is 3, then it goes up to the maximum, which is 7, then it goes back to equilibrium, then it goes down to minimum. That's straight? Yeah, pretty straight. Then it goes back to equilibrium. And now I connect the dots, and I make it kind of curvy looking. And as I've said before, yes, could I figure out these points where it's exactly 0 and all of that? Yeah, I could. For the purposes of this, I don't really care. I just want a rough sketch of the graph. And the thing which I will stress, and I graded your homework, and I mentioned this in the videos before, and those of you who did your homework and saw your grades, if you're wondering why your grades are maybe not as high as they could have been, this is what I want when I see your graphs. I need to see the x's and see the y's, so I can tell you know what all the transformations are. A lot of the graphs I saw on homework were, yeah, I don't know what that is, and I can't read that. Make sure you're sketching these out and showing x values and y values. Now, we can do one more. Do a cosine wave for fun. So f of x equals -2 cosine of 3x plus pi minus 1. So we do the same thing as before, find all of my transformations. The -1 out here will shift me vertically, so I go down 1. The 2 out here will be my amplitude, so I have an amplitude of 2. We keep in mind if there's a negative on the outside, that's going to reflect across the x-axis. Now on the inside, I do the same thing. 3x plus pi, factor out the 3, and I'm left with x plus pi over 3. On the inside, I add, which will shift me horizontally. Addition normally goes right. Since it's in the parentheses, it goes backwards. So this is going to go left pi over 3. The 3 out here is going to change my period. I take the original period. It's a cosine wave, so 2 pi. And I divide it by that coefficient 3. And now my period is 2 pi over 3. Now I have all the information I need. I should be able to sketch the graph. So, same thing as before. And again, I stress, with practice, can you almost look at this and spot a lot of the points and sketch the graph? Probably. I'm not a visual person, and I want to make sure I do it right and don't mess up any of the calculations. I literally do the exact same thing every single time. List out all the transformations, plot the x's, plot the y's, draw the dots, connect the dots. Because that way I guarantee that I'm doing everything correct. So first, let's see. Normally the cosine wave starts at x equal to 0. I'm going left pi over 3. So now I'm going to start at negative pi over 3. Now, my period, to get my ending point, I take my starting point, negative pi over 3, and then you add your period, which is 2 pi over 3. 2 pi over 3 minus pi over 3 is pi over 3, which means my ending point is pi over 3. But now, just for clarity's sake, again, like I said, I don't want to compress this too much. I'm going to put negative pi over 3 over here now, now kind of more or less get it right about here, and that's positive pi over 3. Now find the midpoint. Clearly halfway between negative pi over 3 and positive pi over 3 is 0. Now I need these two midpoints, halfway between 0 and 1/3. If you don't know what immediately, like I said, do the same trick. Double numerators and denominators, 0 is still 0. This becomes 2/6. Halfway between 0 and 2/6 is 1/6. So pi over 6. And then logically, if this is pi over 6, on this side, negative pi over 6. Now I have my 5x values. Now I find my y's. And now keep in mind, normally a cosine wave looks like this. It starts at its maximum value. The amplitude is 2, which means normally I would start at 2. But this is negative, which means I'm going to flip it. And instead of going downwards, it's going to start at its minimum and go upwards. So my amplitude is 2, which means my minimum value is negative 2, but then I also shifted down 1, which means instead of being at negative 2, we'll just make this negative 3. Keep in mind, again, if I kind of sketch it over here, my wave should go from negative 2 to positive 2, and equilibrium 0 is right around there. Because it's flipped, so instead of looking like this, it looks like this. But then since I'm going down 1, I shift everything down 1, so negative 2 becomes negative 3. Equilibrium, instead of being at 0, when I go down 1, is now at negative 1, which we'll say is right there. And then my maximum was normally at 2, shifted down 1, now it's at 1. And now keep in mind, that is the x value for this. I have my 3 y values, maximum, minimum, equilibrium. Now I should be able to plot my points and sketch my graph. I start over here. My cosine wave, we said, is going to start at minimum. So right here. Then at my next x value, it's going to be at equilibrium, which is right here. Then at my next x value, it's going to be at maximum, which is right here. At my next x value, it's back to equilibrium. And then at the last x value, it's back to minimum, up to my ability to get these things correct. And now, if I totally missed that spot, right about there, up and down, and there we go. I can see my cosine wave. And again, I do stress here, your book will sometimes say draw 2 periods of this. If you want to, you can. You may have to do it in Alex. And for some of you, clearly, I'm going to be honest, it looks like you're just using Desmos or something, or even your graphing calculator to graph it. And I see graphs that either look like this, or like I said, they kind of look like that, which makes me think you're just copying it off of something. You don't need to do all of these. And if you are going to do it like this, you have to label all the points so it's clear what you're doing. I am fine when graphing these, always just graphing one period of them, as long as I can see the 5x values, the 3y values, and see it going through the correct points. If there are any other questions about this or anything else, like I've said before, feel free to email me, stop by my office, whatever, and I'll make more videos and we'll go from there.